Hello everybody, this lesson is on rational exponents. By now you should have covered the negative exponent rule and just general exponent rules. This is just adding on to it. And the word rational should be something that you are familiar with when we talk about rational numbers. And so now we're going to talk about rational numbers in the exponent position. So before I begin talking about rational exponents, my first question is, what do you know about what a square root is? Or what's the first thing that comes into your head? And a lot of people, when they say square root, they say, oh, well, the first thing that comes to my head is the word square or squared. And we know that square or being squared has just the exponent 2. Okay? And so just to give you a simple example of this, if I have something like 2 to the power of 2, we say 2 squared, and we know that that's equal to 4. And then if we go back to my initial question of what the square root is, if I were to do the square root of 4, it equals to 2, right? So we're kind of like going backwards, right? We're going this way and then going back with the 4 kind of thing. The general rule for this is just being like anything squared is equal to b, and if I want to, just do the square root of b, it should give me the original a. Okay, so square root the answer, and then you're going to get the original base. So going off like that, though, we should know by now that there are exponents that are not just 2, right? We've seen exponents that are several different numbers. So if we have something like 2 cubed, can we go back like we did here? Can we go back and get our original a if we have exponent 3? So we're going to learn about different types of roots or radicals. So just to start off with, to see a little bit of a pattern. If I do 2 squared like I did before, I can do 4 and do the square root of 4, and that's equal to 2. Now, this little symbol here, okay, alone, without anything in front over here, actually has an invisible mini 2, just to indicate that it's a square root. It's just an invisible little 2. So if I go on and I do 2 cubed, we all know that this is 8. Well, is there a way for me to make some kind of root like this give me the 8? Well, yeah, instead of the square root, we can do the cubed root or the third root of 8, and actually that'll give me 2. And if we continue and we do 2 to the 4, and that's equal to 16, can I go backwards? Yes, I can, because I can do the fourth root of the answer 16, and that will actually give me the base 2. Okay, this sign that we see all the time is also known as a radical or a root. Okay, not now, but probably if I'm teaching you in class, I would show you how to do this on a calculator. And just as a start on the calculator, usually you have something like x root y, and then you would be able to put the number that you want it to square root. Okay, so as we go on, though, we need to figure out the first and foremost. The title of this lesson is called Rational Exponents. So what is a rational number? So if we talk about a rational number, we usually think of a decimal. We could say a decimal that stops or repeats, but we could also think of, or it's a fraction with 2 whole numbers, one on the top and one on the bottom in the numerator and the denominator position. So we are going to deal with fractions as our exponents. So my first example is something like 4 to the power of 1/2. Well, how am I going to deal with something like that? Because this would be like, or 4 to the power of 0.5. Is there something that we can do to make it into not a decimal or a fraction? Well, in fact, what if I just tell you that 4 to the power of 1/2 is the square root of 4? That's what it's equal to. And what if I told you that 3 to the power of 1/3 is just the cube root of 3? Can you try to come up with some kind of rule or some kind of pattern that I'm doing right now? What is going on and what is the same between these two and these two. The general rule when we're dealing with exponents that are fractions is an exponent that is a fraction, like this. All we do is we take what's in the denominator and we put it in front of the radical, and we actually keep the base over here, like that. So that means that if I were to have, say, something like 6 to the power of 1 over 4, I take the denominator, I put it in front of the radical, I put my radical, and I keep my base. And then that's easy. I can totally do this on a calculator. Totally. Okay? So that's the first main rule. But is it possible for me to, instead of having a 1 over, like 1 in the numerator, is it possible for you to have another number in the numerator and have a different fraction? Why, yes. In general, if I have any x and I have an exponent fraction that looks like this, I put the denominator into the radical, I keep the base and the first top numerator exponent. So in general, this comes here and this stays here. So I'm going to give you an example, because obviously the best way to see this is by using an example. So if I were to do this, I would have something like 3 to the power of 2 over 3. So my rule says, well, take my denominator, put it here, put in my radical, keep my base, and the numerator. And this is easy to solve because then I just have this. And I can keep it like this, or I can continue into a decimal form. Let me give you another example. We have 25 to the 1/2. So I take my denominator, I put it into the radical, I keep my base inside the radical, and I have my imaginary 1. Or it's just basically this. Or it's just this. And what is the square root of 25? Well, it's 5. And for the sake of examples, if I have something like 7 root 5 to the 4, how can I go backwards? How can I go backwards for this? Well, simple. You keep the 5 and you keep the exponent 4, and you bring that 7 over in the denominator. Okay, so we basically go backwards. Okay, so just to simplify here in terms of what the rational exponent rule or rules, I'll give you like 3 in general. 1, x to the 1 over n is equal to, you take your denominator, you put it in, and you get x to the 1. 2, if I have x to, say, the m over n, I put the denominator, I keep my x, and I keep the numerator as the exponent on the inside. And if we're going backwards and I have n root x to the m, I keep my x to the m, and I bring over the n to the bottom. And that's pretty much it. Obviously, the most effective way to learn this is by doing several different examples, but my advice for this one is do what's inside the radical first. Okay, so what that means is if I were to give you something like, say, 2 to the power of 4 over 5, if I do the rule, I bring my denominator, I bring my base inside with the numerator on top, you do the 2 to the power of 4 first, and then you deal with the radical last. And that's it for the basics to rational exponents.